thank you for joining me today. My name is Milim, and today we're going to be looking at how the pressure and temperature of a gas are related to each other. So we only have a couple of learning objectives today, and they are to understand how the pressure and the temperature of a gas are related to the kinetic energy of a particle, and to be able to recall that pressure in pascals is equal to force in newtons over area in meters squared. So let's get right into it. So I have here a picture of quite a rubbish balloon, but this square here is meant to represent a sort of zoomed in look into a very small patch of inside that balloon, right? So inside the balloon, we know that it's filled with gas, and so it has some particles inside. Let's draw those particles in. And now from the particle model, we also know that in gases, all of our particles are really spread out. Okay, so we have some spread out particles in there. Now, what we also know is that all particles have some kinetic energy, okay? So these particles are constantly vibrating and they're moving around, and more importantly, they're hitting the walls of the balloon itself. Okay, so now we know that kinetic energy is sort of equal to the temperature of the gas itself, right? If we have a higher kinetic energy in our molecules, the overall temperature of the gas is higher. Why? Because, well, they're traveling faster, they're more excited, they have more energy, right? Energy and higher energies really tend to correspond with higher temperatures. Okay, so now we understand that. Let's get rid of all of our other particles and let's have a look at a single particle. Okay. So we understand that. So we understand the temperature of the balloon, right? But what the hell does this have to do with the pressure exerted in the actual balloon itself? Well, to look at that, we have to actually first look at what pressure is. So let's do that down here. So pressure. So what actually is pressure? Pressure is nothing but the force exerted per unit area. Okay, and that's displayed by its actual equation itself. So we have P is equal P for pressure is equal to force over area. Now let's have a look at some units for this. So pressure has a brand new unit. This is called the Pascal. Okay, so that's just something that you need to know. And the force, as always, is in newtons, and our area is in meters squared. Okay, so what we're looking at here is how much force is exerted per unit area. Let's take our single particle. Our single particle has some kinetic energy, right? So eventually, as it vibrates around the balloon, it's going to hit the walls of the balloon. When it hits the wall of the balloon, is it just going to stay there? No, it's going to bounce back. So we know that when it hits the balloon, it exerts a force. And now, because there are Newton's third law of pair, an equal and opposite force is exerted back out onto the actual back out onto the particle itself. So this sort of force being exerted onto the balloon is pressure. Okay, so let's get that down, right? Force exerted. So remember, exerted means to do upon, right? Force exerted by the particle on the balloon, I hope I spelled that right, is equal to the pressure. Now let's have a look at the link between temperature and pressure, right? So let's do that over here. If my temperature increases, my kinetic energy of my particles increases. So this means that now they vibrate or they travel with a higher velocity, right? They travel even faster. Now, if they travel even faster, they have a higher kinetic energy, and then they collide into the walls of the balloon, they exert a larger force on the balloon. They exert a larger force on the balloon, so the balloon, Newton's third law, exerts a larger force on the particle back. And so we've already said that the force exerted by the particle on the balloon is equal to pressure. So if my particles are traveling faster, they have more energy, they're exerting more force, the pressure in my balloon goes up. So temperature goes up, pressure goes up. This shows a very nice and simple directly proportional relationship. If I double my temperature, I get double my pressure. I hope that's all very clear to you. If not, please go back through the video and pause out wherever you don't understand and really listen to exactly how the logic flows, because as in all of physics, it's all about logic and breaking it down to one step after the next, and I'm sure you understand it.